The purpose of this video is just to review the rules of exponents. So the first thing is we need to identify what the exponent is. As a reminder, the exponent is this small little superscript that we have with either a number or a variable. So we call this number the exponent, and we call the value that the exponent is related to, that is called the base. Okay, so when we go through some of these rules, we might refer to the base and the exponent. The first rule is anytime we raise a base raised to the 0 power. So anything raised to the 0 is always going to be 1. For example, if I had x to the 0, that's just 1. If I had 5 to the 0, that is also 1. If I had a over 6 all raised to the 0, that is still 1. So anything raised to the 0 power is 1. Our second rule is when we have a negative exponent. So whenever we have a negative exponent, we flip the exponent across the fraction bar and make it positive. For example, if I had a to the negative n, that's the same as 1 over a to the positive n. If the negative exponent is already in the denominator, it flips up to the numerator and becomes positive. So 1 over a to the negative n would be a to the positive n. Let's see some examples of this. If I had 1/5 all raised to, actually let's start with just a positive 5. If I do 5 raised to the negative 2, that's the same thing as 1 over 5 raised to the positive 2. So 5 raised to the negative 2 is the same as 1 over 5 squared, which is 1/25. Same thing if I used variables instead. Say I had k to the negative 7th. That's just 1 over k to the positive 7th. If the negative exponent is in the denominator, let's say I had 1 over z to the negative 3. Well, that just comes up to the numerator and it becomes z to the positive 3. So any negative exponent just flips across that fraction bar and becomes positive. The next thing is anytime we have parentheses. If we have multiple things in parentheses all raised to the n, we can just, it's called shower that power. We can shower it to everything in the parentheses. So this would be a to the n times b to the n. For example, if we had 3x all to the 3rd power, that would become 3 cubed times x cubed, or 27x cubed. Same thing if I have a fraction and I'm raising the whole fraction to an exponent. I'm going to raise the numerator to that exponent and the denominator to that exponent. For example, if I had 1/2 to the 4th power, that's 1 to the 4th, which is 1, over 2 to the 4th, which is 16. If I have something already raised to an exponent inside the parentheses and I'm raising it to another power, so this is a power to a power. So when I'm raising a power to a power, I keep the base the same and I just multiply the exponents. So in this case, I would just do m times n in the exponent. For example, if I had 2 to the 6th, and then I raise it to the 4th, that's going to be 2 to the 6 times 4th. So that's 2 to the 24th. A big mistake people make is they want to add these two numbers. It is not adding, you are multiplying. 6 times 4. So x to the 8th squared is x to the 16th. Power to a power, you multiply. Now say you just have two different terms being multiplied together and they have the same base. So a to the m times a to the n, this is when you add. This is when you would just make it a to the n plus n. For example, if I have x to the 7th times x cubed, that's just x to the 7 plus 3. That is x to the 10th. If I had 1/2 cubed times 1/2 to the 5th, I can just add up those exponents. That's going to be 1/2 to the 8th, which is the same as 1 to the 8th over 2 to the 8th. Then finally, we have the quotient rule when you're dividing. So we're dividing, they have the same base, different exponents. Instead of adding them, I'm going to multiply them. Sorry, instead of adding them, I'm going to subtract them. Okay, so I take a and I do m minus n. When you divide the bases, you are subtracting. When you multiply the bases, you are adding. So if I had x to the 11th over x to the 5th, that's the same as x to the 11 minus 5, which would be x to the 6th. If I was doing this and it came out negative, say instead I did x to the 5th over x to the 11th, well, when I subtract those, I would get a negative 6. So x to the negative 6, we already know how to convert that. That's 1 over x to the positive 6th. So just be sure to keep in mind all these different rules when you're simplifying an expression. So we're just going to do this one example that kind of combines all of these rules together. We have a fraction, we have a 0, we have some negative exponents. We're going to have to do some combining. So the first thing I like to do is get rid of all of the parentheses. So right now this whole numerator is being raised to the negative 3rd. So I'm going to take that negative 3 and distribute it, shower it out to each of these powers, and change all of those exponents. So this would be 3 to the negative 3. Then r is already raised to the negative 2. But when I shower this power across, when I do r to the negative 2 raised to the negative 3, that's r to the negative 2 times negative 3, which is going to be a positive 6. S cubed to the negative 3. Remember, your inclination is to add. We're not going to add. We are going to multiply. That's going to be a negative 9. T is raised to the 0 times negative 3. That's still 0. Okay, so I've just simplified my whole numerator. Now a couple things I realize. First, t to the 0, well, we know that's just 1. So it's really this whole expression times 1. Okay, so we can kind of ignore that t to the 0. But now let's combine each of these. We're going to combine the ones that have the same base. So first I see 3 to the negative 3 and 3 to the 1st. Remember, if there's no exponent, it's really a 1. So if I'm doing my exponent rules, I'm going to do 3, so I have negative 3 and 1. So I'm going to subtract those. Negative 3 minus 1. Now I'm going to take a look at my next exponent. I have r to the 6th. R to the 6th minus r to the 1. And then s is s to the negative 9th minus 1. So I now have nothing in my denominator, right? When I simplified all these together, I combined them all together, there's no longer a denominator. This denominator got absorbed into these exponents. So now I have 3 to the negative 4th, r to the 5th, s to the negative 10. Final thing is I can't leave any negative exponents in my final answer, so anything with a negative exponent has to flip into the denominator. So r to the 5th can stay in the numerator, 3 to the 4th becomes positive in the denominator, and then s to the positive 10 also ends up in the denominator. Last thing I'm going to do is 3 to the 4th, because that isn't too big of a number. 3 to the 4th would be 81. So that's 81s to the 10th in the denominator. So that kind of is a good example, has a little bit of everything. Big things to remember is you should never have a negative exponent in your final answer, and you should never have a variable listed twice in your final answer. Like I shouldn't have had an r and an r in the denominator as well. Anything that's the same variable should be absorbed together and created into one simplified expression.